graphical manner, and sometimes this plotting may be such difficult that also creates some problem. Suppose we have this thing x equals to e raised to the power t. So for this x versus t, what about the graph?
Exponential.
Exponential. So when t is equal to 0, x is
X is 1.
1.
1.
sir.
So if it is the x value plotted along this vertical line and time t is plotted along this horizontal line, of course, particle is not moving in this direction. Here is a straight line. Maybe this is the line x along which the particle is taking different position, and that position versus time, these values are given in that form by this relation. Now for t is equal to 0, x is 1. Then what about the t is equal to 1?
2.3.
2.71.
Some more refinement. So if you have to calculate it, just take and place that numerical value for E. You get it? It will be
Sir, 2.71828 है sir.
8281, 8284 something. It's a long range of such values. So it depends on the type of the numerical values which are given and how refinement you need in your calculation. Okay, so if it is required that very accurate calculation is required and you have been asked to find out the result with 5 places after decimal, so definitely you have to take a good value of E, 2.71828182884, but it's not ending in that way. Now similarly, when E is equal to 2, T is 2, it is 2.7, or if it is 1, if it is
7.
so that 2.71 square, so less than 9, that is less than 3 square, maybe it is a 7 or something like that. So here it is 2.71. Then for 2,
7.3.
7.3 or 7.5, whatever you are saying. So ultimately that exponential graph, and there we find, suppose for t is equal to 3, e to the power 3, t is equal to 4, e to the power 4, and that graph is taking, in that way. So for a very small span of time, it is moving really quite high, and this much space may not be available on your A4 size paper to plot that graph. Okay, now what we can do, if we take natural logarithm on both sides, what happens?
Log is equal to t.
Now for different x values, if we take natural logarithm, then what about their values? Definitely in comparison to this value, it is quite less. And for t is equal to 1, 2, 3, etc., that log x, log 1, log 2, log 3, log 4, etc., those are really some manageable numerical values, and we can plot that graph. Now for such kind of plotting, have you used graph paper? Normally in your school you have used millimeter graph along x-axis, millimeter, along y-axis, millimeter. Of course, millimeter, centimeter, those are identified there. Or in some graph paper you have used inches. and 1/10 of inches or something like that. But directly plotting these log values either with respect to 10 or with respect to E. Have you seen this type of graph paper? क्या रे दिखा है तो बता yes, नहीं देखा है तो no.
No, sir.
So
No, sir.
suppose we have some x values and along this x-axis what we do, we directly plot those log values. So when it is 1, then what about the log value? Log value is 0.
Yes.
Now when it is 2, then it is with respect to 10 log 2. For 3 we calculate log 3. In fact, we should not write this log with respect to 10 because the log means it is base 10 and the ln, that natural logarithm, with base e. Anyway, now for 4 we calculate the log value for 4 and we plot those values here. Log 2, log 3, then log 4, etc. Now what about this spacing? For standard millimeter graph or centimeter graph, the space between or gap between 1 and 2, 2 and 3, 3 and 4, those are uniform. But what about this gaps between log 2 and log 3, log 3 and log 4, that is the difference log 3 minus log 2. What about that value?
Sir, log 3 by 2.
Log 3.
That is log 3 by 2, that is log 1.5. Then what about the gap between log 4 and log 3? That is
Log 4 minus
4
log
divided
4
by
by
2. That is
Sir,
log
log 1.333.
1.333. Now this thing, the gap between 2 and 3, it is log of 1.5. Gap between 3 and 4, it is log 1.33. Then similarly, gap between 4 and 5,
Sir,
log
1
5
point,
minus
log
log
1
that,
point,
so it will be
1.25.
1.25. Then what about 5 and 6? Log 5 by log 6, that is 1.16 or something like that. So these gaps are reducing. So if we plot those log values directly, and if at 1 it is 0, then if it is at 2, then for 3 it will be little less than that. 4 will be, that gap will be little less than the previous gap. Gap between 4 and 5 will be less than gap between 3 and 4. Similarly, 6, 7, 8, 9, and 10. Now, what about the gap between 10 and 20? Then 20 and 30, 30 and 40, and 40 and 50. Those will be log 40 by 30, log 50 by 60, log 3 minus log 2, and log 30 by 20. They are same. So you will find the whole information is repeated. Starting from this 10, it will be 10, 20, 30, 40, 50, etc. up to 100. Similarly, for repeating that same cycle from 100 to 1000, you will get the same spacing. If it is between 200 and 300, it will be simply log 300 by log 200. That is log 3 by log 2, that is log 1.5. So it's a very nice thing to have that idea of plotting that exponential graph in the form of a log graph, and those are readily available in market. If you go to some bookshop or stationery shop, you will find the log graph paper. Now, two types of log graph papers are there. One is log, that is both side along x-axis, along y-axis, both are log values, or semi-log graph paper. Maybe along x-axis it is log values and along y-axis it is normal millimeter. Maybe. So along that horizontal axis, suppose these three are the units of 1 to 10, 10 to 100, and 100 to 1000, and the spacing that it is 2, 3, 4, 5, etc. And similarly, it will be log 20, log 30, etc. And afterwards, it will be log 200, log 300. So this whole thing is repeated successively for same gaps between 2 and 1, between 20 and 10, between 200 and 100. Okay, so please study this thing, and from internet you can get readily available those graph papers, and you can try to plot them for exponential plot, for logarithmic plot, etc. Anyway, so this type of information may or may not be always available, so that we can visualize about the pattern of their movement, their velocity, acceleration, etc. Now, yesterday we are talking about this type of relation. Suppose x versus time is given in this form. Okay. So in that case, find the derivatives. First derivative will give you the velocity. But just hold a minute. So this is the simple calculation. First derivative, the velocity, put t is equal to 1, find the velocity, minus 8 inch per second. Acceleration, dvdt, 12t square minus 20, put t is equal to 1, we get this. And obviously directly in this expression, 1 to the power 4 minus 10 into 1 square plus 8 multiplied by 1 plus 12, that is 11 inch. Now this rectilinear motion given in terms of the time, not necessarily it will be given in terms of the time always, maybe some other variable. Now here, that displacement, this is a simple arrangement. One object having mass A is hanging from the ceiling attached with the spring. Now definitely if we pull it down, stretch it and release it, it will start oscillating about its neutral position, and that thing is given in the form of the combination of these two curves, sine curve and cosine curve, and 10 sine twice t plus 15 cos twice t plus 100. So dx dt, d2x dt2, etc. to find the velocity and acceleration. for different time t is equal to 1 second. For the second part, the maximum velocity and acceleration of A. Now maximum velocity, where definitely acceleration will be 0, and acceleration maximum means dA dt is equal to 0, and that expression you put the corresponding 0 value there and get the corresponding time and put it in that expression of acceleration. So this is those calculation. 20 cosine 2 t, 2 multiplied by 15 sine 2 t negative. Acceleration expression is here. Now these angles, sine of something, cosine of something, those are in definitely radians. That you must remember. Okay. Now these things are simple, but you should have some practice. Otherwise, your confidence or your overconfidence will betray. Units in millimeter per second. At t is equal to 1 second, the position, velocity, acceleration that you find. For v is equal to v max, put a is equal to 0. So there a expression here. So 40 sine twice t plus 60 cosine twice t, that is equal to 0. So we get this value. Tan twice t is equal to 1 minus 1.5. Now for this thing we get these two values. Now one is negative. Time cannot be negative, so reject this negative value for time. And here the first positive value, we consider this for Vmax. Replace it in the expression Vmax, in the expression of velocity corresponding to that time, and we get this in millimeter per second, the velocity which is negative. Similarly, maximum acceleration you can find in that way. Now in next example, it is given in the form of some other variable, square of the time t, the acceleration, not that position or displacement x. So x versus t is not there, it is acceleration versus time. So you need to integrate it. So these are the requirement and these are the given values. So when you start solving, you frame the solution steps. What is in your programming language, what is called a flowchart. Anyway, that formal flowchart is not required to do it on pen and paper, but at least somewhere you should note down the requirement, the given values, and the relations. And now the steps what you should follow. The relation is acceleration directly proportional to the square of the time t. Given value at t is equal to 0, displacement is 24 in meter. At t is equal to 6 seconds, displacement is 96 meter and velocity is 18 meter per second. Express x and v in terms of t. So these are the some calculations in short. Acceleration A is kt square, directly proportional to the square of the time, and that is dvdt also. Now in this case, we use this expression dvdt. Now if it was proportional to square of the displacement x, then in that case, which relation we would use for acceleration? V dv dx. Okay, so that we should remember that according to the situation, we need to use those expressions available. Now this is given t is equal to 6 seconds, velocity is 18 meter per second. Put this definite integral from 18 to the instant, the current velocity v, and from that time, the present time 6 seconds to this present time t, and from this integration we get this relation. V minus 18 is equal to 1/3 k t cube minus 216, etc. So this is the expression for velocity in meter per second. Now that v is dx dt. For given value t is equal to 0, x is 24. From this limits of integration, we get the relation here. And another given information at t is equal to 6 seconds, x is equal to 96 meter. Put it here and find the value of k. So k is 1/9 meter per second to the power 4. And you can check this dimension, acceleration meter per second square. It is second square. So definitely k will be meter per second square per second square. So meter per second 4. And xt, this is the relation. Displacement versus time and velocity versus time is this one. So things are simple, but you should do proper practice so that you do not make any mistake. And these are some quite preferred hunting ground for scoring good marks. So naturally, you should save some time while solving these problems. And whatever that savings is there, it will be utilized for other maybe comparatively difficult, but that difficult term is relative. The problem which is very difficult for me, it may be for your case, sir, ये तो चुटकी में हो जाएगा, because you know the trick or you have clicked the exact clue which gives you the very simple solution. Anyway, that confidence you get only from practice. ये आप लोगों ने मैग्नस कार्लसन का नाम सुना है?
Yes sir, case clear sir.
Yes sir, well, first time.
Yes sir. Sir मैग्नस इफेक्ट वाले
800 का हरा दिया इसको।
हाँ, वही मैं पूछ रहा था। तो किसने हराया उनको? वेरी रिसेंटली?
सर
Pragunand.
प्रज्ञानंद.
Yes sir, 16-year-old boy.
So that's it. And it is not simple intelligence and talent. It needs practice also, because at that particular situation, the switch which clicks, that is the main thing. So for some special problem, there are some special key points. If it clicks, then you can solve it very easily, the very small time. But if you approach for some general practice methods, etc., maybe you will reach the solution, but it will kill your time. So please have some practice. Now here is some other problem. Acceleration represented in terms of the velocity. So not necessarily for the rectilinear motion, x versus t will be given. It may be acceleration versus velocity also. For acceleration in meter per second square, velocity in meter per second, these are some known values. T is equal to 0, velocity is 1 meter per second. Determine the distance the particle will travel before coming to rest. Before coming to rest means velocity will be 0 there. So put that velocity is equal to 0, and in that expression find the distance. Now the time required for the particle's velocity to be reduced by 50% of its initial value. What about the initial value? At time t is equal to 0, that is the initial value. Velocity is 1 meter per second. So when it reaches velocity is equal to half meter per second, what will be the time required to reach that half meter per second? So these are some.
Not a good method.
Anything? So this is this relation we have used, a v dv dx.
Sir, but here time is given as 0. So why are we taking x in the first case?
वो तो मैंने पहले ही बताया था बेटा. ये आपका घर है, ओके, ठीक है. आपने किसी दोस्त के पास गया सीधे रास्ते से. Here is your friend's house. Then you start to some picnic spot. Okay, but you are measuring the distance from your home. But you are counting the time from your friend's house where you made that gathering, made that team, and therefrom you approach towards the picnic spot. It's something like that. Not necessarily at the starting point for this movement, you will count the time.
No, sir, understood. Actually, the question is asking for distance. So that is why x is used. Okay, sir, fine.
Okay. So acceleration is having this expression, definite integral for that given values. We get some logarithm here, and the time t is expressed in this form. Now, when velocity is half meter per second, then time t is for this much, and this is the corresponding time. So these are some individual particles movement along a straight line. And here is some dependent motion for connected particles. But before moving to any other discussion, I need to complete that important job. That is attendance. Download attendance list. Downloaded. Then of course I must be confirming this. Yes, it has been downloaded. Here is a fixed pulley. Okay, attached to the ceiling. And over this pulley, a rope is placed in this way. One end is attached to the ceiling at location G. At this end, one block is hanging at this end A. Maybe mass is M capital A, M with subscript capital A. Now, for the remaining part of the rope, we place one pulley. Now, condition normally what we use, these pulleys are frictionless, weightless, etc. And from the center of the pulley, a second mass is hanging. Second block B having suppose mass M subscript capital B, it is a hanging. Now, if we are not interested about the kinetics part, that is what about the self weight, whether there is any applied external force or not. So what will be the situation, whether it will be resting in its position or block A will start moving downward, helping block B to move upward, etc. We forget about that part, but at least if there is any movement, what will be the relation between the movement between A and B? We have used this expression XA plus twice XB is equal to constant. Now, where from we get that? It is simply coming from the length of the rope which has been considered to be fixed. It is inextensible string. Just hold a minute. Now, this distance, it is constant. This distance, it is also constant. Half of twice pi r of this radius of this pulley. Then this length is some other constant, etc. So this length plus this constant length plus this length plus this length plus this constant length, that is equal to the total length. If there is no possibility of any increase in length, then total length is constant. If this is the variable position of this block A given by XA, then XA minus this distance K1 plus this half perimeter K2 plus this distance plus this, plus you can include this also. This is xb minus this distance k1 plus this distance constant half perimeter, maybe it is k3 plus this length, of course including this link part, that is xb, that is the total length that is constant. Do you get my point?
Sir, what is K2?
K2 is this one, half perimeter of this pulley. So this length, this is XA minus K1 plus K2
सर
Plus-
बी दोबारा आ गया ना.
हाँ आएगा, इसमें एक बार XB आएगा,
एक्स बी माइनस के वन पे आया एक बार और दूसरे में एक्स बी पे.
this part plus this part plus this part, that is the total length. Okay, इसमें एक बार XA है, इसमें एक बार XB है, इसमें एक बार XB है, तो दो बार XB आएगा, एक बार XA आएगा. And if we arrange all these constants clubbed together, minus K1 plus K2 minus K1 plus K3, etc., it is equivalent to some other constant. You find the time derivative, this will be velocity of A plus twice Vb, that is equal to 0. Another time derivative, you'll get acceleration of A plus twice acceleration of B, that is equal to 0. So
Sir, there is another method, na? By pulley method, we can do like velocity of pulley is equals to V1 plus V2 by 2, where V1 and V2 are the velocities in the component strings.
okay, these are the formula. And whenever you are talking about the spring, then naturally we are talking about the force developed in the spring due to compression or tension. But including that item force, it is coming under kinetics. For the time being, we are keeping it apart. Only the geometrical relation. The geometrical relation is that the total length is constant. And when that total length is constant, from this diagram we get different parts. One is this straight part, other is this constant or fixed distance semi-perimeter part, another straight length plus another straight length. Now these two straight lengths include the distance xb. Of course, with xb you have to add something here, deduct something here, etc. But ultimately variables are xb, xb and xa. Remaining parts are constant. This is a constant distance from the ceiling K1. This is the half perimeter constant length K2. Here is another length K2 and this distance K3, etc. So all such things are constant, and club together all these constants to give you a final constant thing. So position of A, if this is defined as x direction for movement, distance of block A from this reference line, that is the ceiling, and difference, rather the distance, and distance of block B, those are related to this expression. So in this way, those are connected. One XA distance, including so many constant things, plus two xb distances, including and subtracting other constant lengths or distances. This is the basic relation that we must understand. And the pulley, whatever you are talking about, it is nothing differently considered or anything. This simple geometry is considered there. Whatever formula you are using, we must know what is the first principle for that formula, how it has been generated or developed. This is that principle. Total length is constant because the string is inextensible. Okay. Now, once this relation is there in your hand, then it's fine. First derivative relation for velocity, va plus twice vb is equal to 0. Acceleration, a plus twice ab, that is equal to 0. Now, what about this expression? If the block A is moving downward with some velocity 5 meters per second, then what about the block B?
Sir, it will move upward with velocity 2.5 meter per second.
So VB is minus VA divided by 2. So VB will be 2.5 upward and VA is 5 meters per second downward. So it will be 2.5 meter per second upward. From our common sense also we can understand, but if there is some more information to confuse us, this is basic relation will help us, which is coming from this fundamental idea, that is the total length of the string is constant, because it has been said that the string is inextensible. Neither you can shrink it nor you can stretch it. Okay, so similar kind of situation we can handle. But one thing, what about the relative velocity of B with respect to A?
Sir, 7.5.
The relative velocity of B with respect to A, that is VB minus VA in vector form. It will be simply the difference between these two vectors, velocity vector for B and A. And we must understand the direction. If it is positive direction, then what about VB is minus 2.5 and VA is positive 5, so minus 5, that is ultimately minus 7.5 meter per second. So velocity of B with respect to A. With respect to A, it is moving upward. So this negative sign is there. If it was velocity of A, relative velocity of A with respect to B, so with respect to B, it is moving downward, so it will be plus 7.5. So that relative velocity part may be included in some problem. So please include this calculation and that idea. And if it is possible for you to understand what will be the relative motion of B with respect to A or that of A with respect to B, it will be giving you some confirmation. Otherwise, simple mathematics will reach you to some required thing. Okay. Now, similar situation, it may be here. Here we have 4 pulleys. 2 are fixed with the ceiling and 2 of them are moving. So for this pulley, there will be some movement. See, for this pulley A, there will be some movement, or this pulley is attached with this block. This link length is fixed, etc. This lapping length, half perimeter over this pulley. If we assume all pulleys are of same dimension, so this lap length, this lap length, this half twice per year lap length, and here these are the part of the rope which are fixed length. Now this distance XA coming twice here for this part and for this part. So twice XA plus for B 2 times it is coming plus this position for C XC is coming only once, and when we include this length, subtract this length, add this length, subtract this length, etc. Ultimately, that is the total length of the string, where variables are position of A, B, and C, and that is equal to constant, some K. First derivative, velocity A, velocity B, velocity C, that is 0. And next derivative, acceleration, that is equal to 0. So this type of simple things you will always find, but you need to do proper practice. Otherwise, it will be very difficult for us to handle the situation. Now, this problem.
Sir, we have another class, sir.
Okay. So please leave. Okay, join your class. So in our next class, we will continue this discussion. But in the meantime, you do some practice. Okay.
So can you send these examples via mail?